All right, continuing on in chapter 2-2, polynomial functions, we can tell and determine what the end behavior is going to be of a function, depending if we are looking at the leading term. In fact, we're talking here about, this is on example 2, page 99, where we're going to be applying the leading term test. And of course, we've got to make sure that our function equation is written in standard form with the variable raised to the highest degree in the first position. That's therefore the quote unquote leading term. And if a function is being raised to an even degree, squared to the fourth, to the sixth, so on and so forth, and the leading coefficient, or the coefficient of the lead term, is positive, we would expect to be arms up. If it's raised to an even degree and that lead coefficient is a negative, we'd expect to see our end behavior arms down, what we call arms down. But in this particular function that we're looking at, 4x raised to the fifth power minus 8x cubed plus 20, our leading term is raised to an odd exponent. And so on odd exponents, we are looking at either left arm down, right arm up, or vice versa, left arm up, right arm down, and we can determine that part from the coefficient of the lead term as well. And if it's positive, as this one is, we would expect our graph to have a left arm down, right arm up. And if it should be negative, it would be left arm up, right arm down, or disco right, disco left. So let's see. We've got here a positive 4x to the fifth, so we're going to be expecting a graph that's going to look something similar to that. And if we were to then describe that in limits, we would say that we're going to have a limit as x is approaching negative infinity, then f of x is also going to be headed towards negative infinity, and also a limit as x is approaching positive infinity. We would be expecting f of x to be headed towards infinity. And that's because we've got an odd power with a lead coefficient that is positive. So let's take a look here at our graph and see if that confirms that. And so I had graphed this equation, or function, and we do in fact see that we've got a disco right, which means, another way of saying that is we got the left arm headed down, we got the right arm headed up. As x is moving towards negative infinity, f of x or y is also moving towards negative infinity. And as x may be headed off towards infinity, well, f of x or y is also headed towards infinity. We'll take a look at one more. Now, in this case, our function is negative 2x raised to the sixth power plus 11x to the fourth power plus 2x squared. And so our leading term, we're applying the leading term test. We're looking here at this lead term. And it is being raised to an even power to the sixth power. And so then I am expecting that our end behavior, both left and right, is going to be headed in the same direction. But because this coefficient is a negative 2, I'm going to see we're going to have something similar to a graph that's going to have this general shape. It should probably have some jogs in it, actually, some different turns. But the end behavior is both going to be going towards negative infinity. And if we write this again in terms of limits, as x is headed into or approaching, guess I should put a little arrow there, negative infinity, f of x, and I guess I really should put in the equal, is going towards negative infinity. And as x is headed towards infinity, well, then f of x is going to be going towards negative infinity, going in the same direction. It's being raised to an even power. Let's take a look at the graph of this function. And let's see. I've set my window setting so we could see some of these jogs just for the fun of it. Because it's going to kind of give us an idea of what we're looking at in the next lesson. But I can see here, I set my window settings to y equals negative 60, y 60, so I can get as much of this picture in as possible. As x is headed towards negative infinity, well, in fact, f of x or y is going towards negative infinity, and as x is headed towards infinity, well, again, still, f of x or y is going towards negative infinity. Now, next up, we're going to be able to continue to add to our analysis of this leading term to where we can identify how many possible real zeros the function may have and the number of turning points that we should expect there in the graph of the function.